So you want to build the super intelligent machines of the future? Well, a fascinating new field called NeuroAI thinks we're looking in all the wrong places. It says we shouldn't be staring at code, but at the animal kingdom. Yeah, you heard that right. The path forward, it turns out, might actually be backward.
All right, let's just dive right in. And we're going to start with this really weird paradox, something that's right at the heart of modern AI today.
I mean, really think about this for a second. We've built these incredible AIs, right? They can master Go, which is just one of the most complex board games humanity has ever come up with. They can crush the best players on the planet, and yet, we have not built a single robot, not one, that can do something as simple as walk over to the shelf, grab the game box, and just set up the pieces.
And you know, this goes way deeper than just board games. The kinds of basic skills that most animals just do are totally beyond our most sophisticated AIs. We're talking about things like building a nest, or foraging for some berries, or even caring for its young. These are such fundamental abilities, things that evolution perfected over millions of years, and for our smartest computers, it's still pretty much science fiction.
So this is the big question, the one that really drives this whole thing. Why is there this massive gap? How can an AI calculate billions of possible moves in a game like Go, but completely fail at tasks that a 4-year-old or, heck, even a mouse finds totally effortless?
And here's what's so fascinating. The answer to that question? It's actually hidden in AI's own history. A history that, for some reason, we've kind of forgotten about, or maybe chosen to ignore.
See, neuroscience wasn't just some small side influence on AI. It was the spark for its biggest breakthroughs. Back in the 40s, you had John von Neumann using the little we knew about the brain to basically invent modern computer architecture. Then in the 60s, research into how a cat's visual cortex works, that directly led to the deep convolutional networks that power pretty much all modern AI vision today. And the entire field of reinforcement learning, that came straight from studying how animals learn from rewards and punishments. It's all connected.
But somewhere along the way, that vital connection just faded. The two fields, AI and neuroscience, they just drifted apart. And that created this huge, gaping missed opportunity. We got so focused on pure engineering, on bigger computers and massive data sets, that we forgot to look at the original blueprints. The blueprints from the most successful intelligent systems on this planet, actual living brains.
And that's where the NeuroAI bridge comes in. It's a new movement that's all about rebuilding that essential connection.
It's a field called NeuroAI, and the core idea is actually pretty simple, but it's also incredibly powerful. It says that if we're serious about building truly intelligent machines, we have to get serious about understanding how real brains actually work, how they compute. Because all the magic ingredients we're looking for, flexibility, common sense, incredible efficiency, they're all right there, just waiting for us to figure them out, to reverse engineer them.
So if we're going to take this new approach, it means we need a new goal for AI, a totally new benchmark for what intelligence even means. Something way more meaningful than just winning a board game or passing some kind of chat test. For decades, right, the big goal was the classic Turing test. It was all about language. The big question was, can a machine talk like a human? But NeuroAI says, nope, that's not the real test. It proposes a much, much tougher challenge, the embodied Turing test. The question is no longer, can it talk like a human? Now it's, can it act like an animal?
And that makes the goal so much more concrete, doesn't it? Forget about a chatbot. Instead, imagine trying to build an artificial beaver that has to build a real, functional dam. Or an artificial squirrel that has to actually leap from branch to branch through a forest. See, this forces you to solve the real problems, perception, movement, and how to deal with a messy, unpredictable world.
Okay, so what would it actually take to pass a test like this? Well, an AI would need to get really good at 3 key things that animals are just naturally amazing at. First, purposeful interaction. That means moving around and actually manipulating things in a complex world. Second, behavioral flexibility, the ability to adapt when things change, to handle situations you weren't explicitly trained on. And third, something called computational efficiency.
And that last point about efficiency, honestly, the numbers are just staggering. Get this. Your brain right now is running on about 20 watts of power. That's a dim light bulb.
Meanwhile, training just one of these big AI models can burn through over 1,000 megawatt hours. That's enough electricity to power a small town for a while. Nature is just unbelievably efficient. And when you compare it, our modern AI is just shockingly, incredibly wasteful.
Okay, so this is all great, but how do we actually do it? What's the plan? Well, the cool thing is, the researchers behind NeuroAI aren't just pointing out the problem. They've laid out a pretty clear three-part roadmap for how we get there.
Step 1, we need a new generation of researchers, people who are totally fluent in both neuroscience and AI, who can bridge that gap. Step 2, we need to build a shared platform. Think of it like a giant particle accelerator, but for AI, where we can develop and test these virtual agents, these artificial animals on a massive scale. And step 3, we've got to keep supporting that fundamental, boots-on-the-ground research to really reverse engineer the principles of the brain.
Now, you might hear people push back on this. The common argument is, hey, engineers don't study birds to build better planes. And that's true, to a point. But the researchers have this fantastic comeback. They say, sure, if all you want to do is fly really fast and really high, a jumbo jet is what you want. But what if your goal was to build a machine with the agility of a bird? Something that could fly through a dense forest, dodging trees, and then land gently on a tiny little branch. Well, then you would be an absolute fool not to pay very close attention to how birds do it. The goal isn't just speed, it's a different kind of capability.
And that really leaves us with a final kind of provocative question to think about. What if this whole quest for artificial general intelligence has been aiming at the wrong target all along? Maybe, just maybe, to build a truly artificial intelligence, we first have to master artificial animal intelligence.